So we're looking at the commutative property of addition and multiplication, as well as the associative property of addition and multiplication. For the associative property of addition, changing the grouping of the numbers in a sum does not change the sum. Notice the example on the left. 5 plus 4 plus 2, if we decide to add 5 and 4 first and then add 2, that won't change the sum if we decide to add 4 and 2 first. This would only work for addition and multiplication, meaning it would not work for subtraction and division. And you should go ahead and try it and see. We can change the order adding and multiplying, or we can change the associating, but only for addition and multiplication. Alright, let's look at the commutative property of addition and multiplication. In a sum, you can add the numbers in any order. Notice the example on the left. Now, even though multiplication is being demonstrated here, we could add the numbers in any order that we want to. A plus 4 plus 2, or A plus 2 plus 4. We can change the order if we like. In a product, we can multiply the numbers in any order, and you're seeing the multiplication being demonstrated. So with respect to the commutative property, if we change the order of the numbers, and this is only for addition and multiplication, the answer will still be the same. It won't change the answer. That's only for addition and multiplication. And again, for the associative property, when we're grouping, if we decide to add the first two or multiply the first two and then the third, or change the order of the multiplying or the grouping, that won't change our order. Our answer, I'm sorry. Let's go on to our first example. Okay, you buy a portable CD player for $48, rechargeable batteries with charger for $25, and a CD case for $12. We need to find the total cost. The total cost is the sum of the three prices. We're going to use properties of addition to group together prices that are easy to add mentally. So 48 plus 25 plus 12. Okay, so when we're doing mental math, you want to add the ones that are easy to do first, and again, the order ultimately won't matter, but nonetheless. So I'm going to group the first two, and then we'll add the last one in. 48 plus 25, and again, it really doesn't matter which one the order that I put them in. Okay, either way our answer will come out the same. So just right here, I use the commutative property of addition, and I'm abbreviating it there. And I'm also going to demonstrate how I could use the associative property of addition. Associative property says I can associate who I want with whom I want to. So let's say that 25 doesn't want to hang out with 48 anymore, so we'll say 25 plus the quantity of 48 plus 12. This is the associative property of addition. And notice how I not only name the property but also tell whether or not it's addition or multiplication. You would have to make sure that you did that. Anyhow, let's just go ahead and add these together. So we would have 25 plus 60, which gives us 85. The whole point is to know how to identify the properties. So the total cost is $85. Let's look at another example. We want to evaluate 4xy when x equals -7 and y equals 25. And I'm going to explain each step as I work it through. Okay, so 4xy becomes 4 times -7 times 25. And so we use order of operations, and there's only one operation here, multiplication, so everything's getting multiplied times one another. And you have to be able to demonstrate different properties. So I'm going to use the commutative property of multiplication. So meaning I'm changing the order. -7 times 4 times 25. I just used the commutative property of multiplication. And now let me also demonstrate the associative property. The associative property says we can group or associate however we want to. So maybe here, if you decided to do the first two numbers originally, but then we say, hey, let's change the association. So -7 will be multiplied by the product of 4 and 25. We'll multiply those first. By changing the association, I've used the associative property, the associative property of, anyhow, I'm just demonstrating those properties. Let's go ahead and multiply these. This will be negative 7 times 100, and I did those two because they're easier to do mentally. And we multiply this, we get negative 700. On to another example. We want to simplify the expression. So always we're looking to use order of operations, okay, and the operation is addition, so we can just go from left to right. Let's say we decide, I'm going to do these two first, okay, or what if we decide to change it? What property would I use if I write it this way? X plus the quantity of 3 plus 6. What property is this? Hopefully you're thinking this is the associative property of addition. And we would have to use this property because these are the only two that can actually be added together. So we use that property. So then this will become x plus 9. And we would have to leave the answer right there because I can't combine a number with a variable. So we have to leave it in the expression. Alright, and then on to the next example. 4 times the quantity of 8y. What if I change this to say 4 times 8, let's do those two first, and then multiply by y. What have I done? I have used the associative property of multiplication. So let's go ahead and do that. 4 times 8 is 32, and we're still multiplying by y, and I would just have to leave it in this form. Multiply 4 and 8. Okay, identity properties. When 0 is added to any number, or when any number is multiplied by 1, the result is identical to the original number. These properties of 0 and 1 are called identity properties. And the numbers 0 and 1 are called identities. Let's look at the identity property of addition, also known as the additive identity. Okay, two different ways to say the same thing. The sum of a number and the additive identity, 0, is the number. So, for example, if I have negative 6 plus 0, the sum of a number and the additive identity, which is 0, is the number. That's what the property says. Okay. Let's look at the identity property of multiplication, otherwise known as multiplicative identity. The product of a number and the multiplicative identity, which is 1, is the number. Basically saying that anytime we multiply a number times 1, we get that number. That's what the property means. Alright, let's look at another example here. The whole point here, you have to learn how to identify properties. Okay, so various statements are given. We need to see what property is being illustrated. For the first one, negative 5 times 1 equals negative 5. What property is this? This would be the identity property of multiplication. And I'm going to abbreviate the identity property of multiplication. Alright, because we got the original number. For the next one, 2 plus negative 9 equals negative 9 plus 2. What happened here? What property did I use? I changed the order, meaning commutative property, and I'm going to abbreviate that. This is the commutative property of what's math operation happening? Addition. Can only work with addition and multiplication. Next one, y squared plus 0 equals y squared. I just used the identity property of addition. This is a demonstration of the identity property of addition, okay? Because I got my original term. Lastly, 2 times the quantity of PQ becomes the quantity of 2P times Q. What property did I use? This would be the associative property of multiplication, because I changed who was what numbers and variables were associating with what numbers and variables. So I changed the grouping. Associative property of multiplication, since that was the operation that we were engaged in. Unit analysis, also known as dimensional analysis. You can use unit analysis to find a conversion factor that converts a given measurement to different units. For example, the sample that you're looking at now, we are in the process of converting feet to inches, since 1 foot equals 12 inches and 12 inches equals. So the identity property of multiplication tells us that multiplying a measurement by a conversion factor does not change the measurement. Okay, let's look at our final example. Okay, roller coasters. The Steel Dragon 2000 is the world's longest roller coaster. Its length is 2,711 yards. How long is the roller coaster in feet? Step 1, we need to find a conversion factor that converts yards to feet. So the statement 1 yard equals 3 feet would give us 2 conversion factors to choose from. Either we're going to choose 1 yard over 3 feet or 3 feet over 1 yard. Which do you choose? Well, unit analysis shows that a conversion factor that converts yards to feet has feet in the numerator and yards in the denominator. This we must arrange so that when we're going from yards to feet, look what happens to yards. Yards cancels here, and we're left with feet. So that's definitely what we want to have happen. So we should definitely be using the second factor. Okay? So what we do now, we multiply the roller coaster's length by the second factor. So let's see here, 2,711 yards equals, oops, forgot my comment. So we're multiplying by the conversion factor, which is 3 feet over 1 yard. And I abbreviated, sorry. But at any rate, look, my yards cancel. I use the conversion factor, and now I'm going to multiply 2,711 by 3 feet, which will give us 8,133 feet. So the roller coaster is 8,133 feet long. And that's it.